Hello Humanoids, this is Robotics and it's me Harishankar. It's been a long day. I hope you all safe and doing good. So what we are going to see in this video. Earlier I have done a surveillance robot using ESP32 Cam Module. I got a pretty good response for that one. So I have decided to make an upgraded version with 3D printed parts. I attached two servo motors for pan and tilt movements. Also, I have done a few enhancements to the robot that we can see it in the video. Before we start, if you are new to this channel and not subscribed, please subscribe the channel for more robotic project videos. Like and share the video. If you have any doubts or suggestions, you can ask me in the comment section. Let's see how to do that.
These are the components that we are going to use. First, 3D printed parts. You can find the 3D files in the description. I have used basic Cura setting to print all the parts. Next, 4 BODC motors. Next, L29A10 motor drive. ESP32 Cam Module. TTL USB module to upload the program. Two SG90 micro servo motors. LM2596 DC to DC buck converter. Next, 12 volt battery. A small on-off switch. A bunch of jumper wires and ribbon wires, and also adapter cables like this. M3 30mm screw for DC motor assemble. M3 nuts. M3 10mm screw for chassis assembly. I made a small circuit to connect the servo motors. And finally, female header pins. First, we'll start with soldering some wires to the DC motor. We should solder the wire like zigzag because both DC motors are facing opposite direction. Now we can assemble the DC motor with the chassis. Use M3 30mm screws and nuts. Now assemble both parts with the base of the chassis. Now assemble front and back parts to the chassis. Use the same M3 30mm screw. Now I am going to connect the DC motors with motor drive. Once that is completed, now we can upload the program to ESP Cam module. This is the circuit diagram to connect TTL module with ESP32 Cam. Connect USB module VCC pin to ESP32 5V. Next, USB module ground to ESP32 module ground pin. Next, USB module receiver pin to ESP32 module transmitter pin. Next, USB module transmitter pin to ESP module receiver pin. And finally, connect ESP module ground pin to ESP module IO0 pin. To upload the program, we need ESP32 board manager. If you don't have that board manager, please follow the steps to download. Click on Files and select Preference. Here, open Board Manager URL field. Here, you have to copy and paste ESP32 Board Manager URL. You can find the URL in the description. Click OK and close the window. Now select Tools, Boards Manager. In the search field, search for ESP32. Once you find, click Install. In my case, it is already installed. Now close the window. This is importing part. Here we have to include all the necessary files. Since we are using ESP32 Cam module, we have to define and enable AI Thinker model. This is Wi-Fi credential section. Here you have to enter your Wi-Fi network SSID and password. Here I am defining DC motor pins, pan and tilt servo pins and flash pins. Here I am defining some initial values. This is the command handler part. For every incoming request, the command handler will be executed. Based on the command and the value from the request, this will be executed. To control the flash, I am sending a request variable as flash in the request. If you see the design part, you can understand. As you can see, for every button click event, I'm calling control server with two parameters called variable and value. Based on this, I'm controlling the robot. If the request is for control, the command handler method will be executed. Here, based on the value from the request, the flash LED will be controlled. Here, we can control the speed of the robot. This part is to control the direction of the robot. In this part, I am controlling pan and tilt servo angles. This is for index page design. If you want to add any other features or design, you can add here and you have to control it in the command handler. Here I have written a separate function for defined and initializing DC motors, servo motors and flash. Everything in the robot like DC motors, servo motors and flash will be controlled by PWM values using LEDC package that you have included. In case if you want to know more about LEDC package, you can refer online. This is to connect the robot with local Wi-Fi network. Based on the SSID and password, it will be connected. Make sure that you have entered correct SSID and password. Once all ready, choose the following settings and upload the program. In case if you find any difficulty while uploading the program, press the boot button. Once the program is uploaded, remove the GPIO 0 pin and ground pin. Once the connection removed, press boot button. Here ESP32 will try to connect to your local Wi-Fi network. Once it is connected, you can able to see the IP address. Note down the IP address, you have to use it later. This is the full circuit diagram of the robot. You can also find it in the source files. Now we can assemble the remaining parts. I am connecting the small switch here. To on off the robot, I am soldering the positive wire from the battery to one end of the switch. For another pin, I am connecting two wires. One will be connected to the motor drive for DC motors and another will be connected to the buck converter to power the ESP32 Cam module. Now I am connecting all the ground pins together. One is from the battery and another one is from the motor drive and finally from the buck converter. This is for buck converter and connect the another pin to the motor drive. Connect the 12 volt input from the switch and ground to the motor drive. Now we can connect the 12 volt battery and we can check whether it is working or not. As you can see, when I switch on, the motor drive is getting power. I am using 5 volt out from the motor drive to power up the servo motors. So I am connecting a small jumper wire for that. For easy access, I am not soldering directly to the ESP32 Cam module. Instead of that, I am using these female header pins. Refer the circuit diagram and connect all the wires. This 4 wire is to control the DC motors. These 2 wires is to power up the cam module. This is to control the fan servo. And this ground is for servo ground and this is to control tilt servo. Now connect the DC motors controlling pin from ESP32 Cam module to the motor drive. Now I'm going to assemble the buck converter. Before that, I'm going to solder some female header pins to it. Once the soldering is done, use M3 30mm screw and assemble it on top of the chassis. Now connect and check it is working or not. As you can see, it is working fine. Now we can't directly apply 12 volt from the battery to ESP32 Cam Module. So I'm going to reduce the voltage to 5 volt. Use the potentiometer in the buck converter to adjust the voltage. As you can see, I have adjusted to 5 volt to power the ESP32 Cam module. Now assemble the ESP Cam module with the 3D printed case. I have made a small circuit to connect the pan and tilt servo motors. This is for 5 volt power and ground pins, and this is for signal pins. Now we can directly connect the servo motors here and the signal pins separately. Now use M3 30mm screw and assemble it on top of the chassis. For servo power pins, I am using this 5 volt out from the motor drive. For ground, I am taking from ESP32 module. Now fix the header pins to the ESP module. Make sure that you are connected properly. Now I am soldering the power pins with buck converter to power the ESP Cam module. Make sure that you have adjusted the voltage to 5 volt. Now connect the ground and pan and tilt servo signal pins to the circuit. Now I am connecting the servo motors. Make sure that the servo motors power and signal pins are connected properly. Once all connected, power on the circuit. The servo motors will move to the initial position, which is 90 degree. Now we can assemble the pan and tilt servo motors with the chassis. First, assemble the pan servo with a base and screw it. Now, assemble the base on top of the chassis. Now, assemble the tilt servo. Assemble the side parts to ESP32 cam case and assemble it with the tilt servo. Once all assembled, use a cable tie to join all the wires. And make sure that the pan and tilt servo motors are moving freely. Now we can assemble the track wheel and track belt. Once all assembled, now we can screw the top part. All good. It's time to test the robot. Switch on the robot and open Google Chrome. Here, enter the IP address that you have noted. As you can see, the camera is working fine. Now, you can control the robot using the buttons on the screen. As of now, the robot will be controlled only in local Wi-Fi network. In the upcoming video, we'll see how to access the robot from anywhere. Thanks for watching the video. We'll see you in the next one.